Hey everybody, it's live app review. Today we're going to look at the marketplace contract with enumeration. We'll go over that, the enumerable sort of spec and some methods there. We'll also talk about making bids, not bids, but making sales in fungible tokens and purchasing NFTs with fungible tokens. We'll talk a bit about royalties as well. We'll look at the newly changed spec for doing royalty payouts and how that works. So three areas to go over: enumeration of NFTs, basically, selling and buying with fungible tokens, and paying out with royalties. So without further ado, I'll share my screen. We've also got Vadim and Trevor here to just kind of make sure that make sure I don't do anything stupid. All right, so I've reorganized the market simple contract, but actually I don't think that's the best place to start. I think what we'll do is we'll start here with NFT simple. So I added a couple of extra files and sort of features above and beyond the NFT simple spec that is in core contracts. So if you do go to the core contracts repo, I don't know why I default to the lockup contract. If you go to the core contracts repo, there's a few different branches. One of them is NFT simple, which you'll find an implementation there, but that's a little out of date. There's another branch. This is all moving very fast. We're going to merge this branch soon, but this is the latest commit. It's under the, for some reason, it's under the feature approval callbacks branch that I started quite a while ago. But this was the latest commit from Evgeny, Eugene the Dream, as some call him. There's source, test contracts, test simulation. I've mostly just been working off of this source, but you'll notice there's a difference between that source and my source. I have added the safe fraction type, which I borrowed from Thor at Mintbase. And that is to do with the royalty payouts, which I'll talk about in just a sec. But I also added the just a very simple one that we should start with called the enumerable.rs. So this implements the enumeration for the contract. So nothing about the tokens or the general contract data structure needed to change. You'll see the token.rs is sort of been updated here and split into token and JSON token. It's just a bunch of sort of optimization cleanup of the NFT standard. This is the main contract. So I didn't have to change anything from Eugene's implementation here. All I had to do was sort of just navigate whether or not the user has tokens or not. And the reason I'm kind of doing this for the NFT supply for owner, and I'm doing that again here for NFT tokens for owner, I'm checking whether or not the owner actually has any NFTs. And if they don't, I'm just returning 0, or I'm returning an empty vector. And the reason for this is, like, we don't want these view methods to panic all the time. We just want them to come back and say, oh, does Vadim have any NFTs? 0, or empty, empty array. I will also show you. So we define our specs here in nomicon.io, and down here you have enumeration. So it doesn't specify that the return should return 0, but I have a PR in for that I just put in this morning. So we're moving, pretty fast, but we're pretty much at the end of the NFT standard as it is. But anyway, this defines the enumeration. So I've just adhered to the sort of standard here, but instead of the TypeScript types, which it's written in, don't know why. Thanks, Chad. Just kidding. Instead of using TypeScript types, you'll notice it's all written in Rust. Anyways, long story short, you basically have NFT supply for owner. So you can basically say, hey, how many tokens are there for this owner? Just convenience method, you know. You can get the some NFT tokens, and you can get NFT tokens per owner. Now, one thing you'll notice right away is that there's a from index and a limit. So let me just explain the nuances here too, because this can kind of trip up some people. Okay, so all things being equal, Vadim has 1,000 NFTs. Lucky guy, right? So he's got 1,000 NFTs, and I am some front end application, NFT gallery, etc. And I want to show, you know, the first 20 of these NFTs. So I would say, you know, NFT tokens for owner, account ID is, you know, vadim.near, from 0, and limit 20. And that would get me the first 20. Then I could say from 21, you know, 20, and that'll get me 21 through up to 40, right? Now, the issue here is that some people would say, hey, but I thought, you know, tokens by owner ID is an unordered, it's an unordered set of token IDs. What's going to happen? What's going to happen? Oh no, you know, you know, Vadim's going to be paging through his NFTs, and all of a sudden they're all going to be jumbled on page number 5. And this is true if Vadim is simultaneously paging through his NFTs, but also you know, like basically removing NFTs or transferring or selling or whatever, or NFTs are being sold while he's going through his gallery. Now, there may be a situation where an NFT from page 5 could swap all the way to page 1 because an NFT in page 1 sold, and in order to keep the data structure, you know, quote unquote lean, we like swap them in. That's fine. As far as we're concerned with this spec, I talked to Mike about this last night, Mike Purvis. And as far as we're concerned with this spec, we're not making any guarantees about the order. We're just basically saying, given that there is some set of NFTs per owner, you can page through them, you know, and provided it does not update while you're paging, nothing should change. So you'll get a consistent pagination during that period in time before any updates to the actual set. So we don't, again, like, we're not here to like build everybody's application and make it perfect, but I'm just talking about some of the application specific implications. So maybe I want to ask Vadim, Trevor, what do you guys think about that? Do you have any questions on that point?
I just want to ask, maybe, shall we prevent somehow behavior when somebody will just ignore limit and put, I don't know, 1 million all the time? So it will lose our
question.
RPC.
Oops. I made that pretty big. Yeah, so you'll notice here, Vadim, I checked min here. So I check, I basically take the min of the keys.length. So I take the min of the length of the key of the set. So basically you can only really go from the start index that the user wanted up to the length of all keys in the set. So it doesn't, it actually, in my test, it's funny you mentioned that. In my tests, I've got these enumeration tests. Where are they? Oh yeah, I specify, it's all the way over here now. Okay, I can't see it under the Zoom stuff, but I specify from index 0, limit 1,000, but it doesn't affect anything. It just goes, you know. I think yeah, it's just down here. So enumerable tests with no tokens, enumerable tests with after minting tokens. So yeah, so you do want to prevent that. That's a good call there. I guess actually one thing you mentioned, Vadim, it makes me think about this now. I don't think I actually protect against the from index. So I think you could put start in front of end, but I think at that point the loop won't work. So let's try it. So enumerable test, there are no tokens in this set. So let's just even go like something really stupid. Let's try. Let's try it. Actually, there are no, there's no tokens in the Bob set the next time you run the test. But anyway, we can just let that run in the background as we sort of discuss stuff. I actually don't know what would happen. I think the loop just doesn't go, right? Vadim, you're muted.
Yeah, I guess Rust is smart enough. It will just break this loop.
Yeah, I think it'll just break out because this will just be false from the beginning. So
yeah.
It'll just not go.
No, just what I really wanted to mention that, for example, if we will have one NFT contract like Paras, I checked it's few megabytes, and maybe somebody will just
wait, it's a few megabytes.
Yes, the state of the contract. I just checked on Explorer.
Oh, you mean the state, like the storage that it's occupying. Oh, well, that's still kind of impressive. I thought you meant the contract bytes itself.
No, the state. So if somebody will just grab all this data without setting limit, or he will put like something like really high, for example, few 100,000, and every front end will load 100,000, so it will overload probably our nodes. So maybe we can prevent setting this limit too high. Maybe not. You cannot, like API servers are doing. You cannot request more than 100 lines, for example. It can be set in the specification maybe, but I don't know how can we push every programmer to implement this.
Yeah, I mean, what's going to happen actually is that they're going to hit like an RPC limit. So basically, what will happen? Okay, so you don't pay for reads. However, reads are still metered and reported to the node that received the request. So basically, as far as I know, the node is going to take it in and it's going to start reading storage state. And as it reads storage state and tries to do this loop, it's going to actually meter, and it's going to, even though it is a read where the gas is not charged, it's going to meter and stop and say, and get out. And it's just going to panic. It's going to say, sorry, your read is too long. It's too aggressive. Something. I actually don't know exactly, Vadim, like, but I know that that's the general like philosophy. I don't know what the error is though, because I've never done it. We should. Do you want to fill up a contract on testnet and let's?
Yeah, we easily can do it. Yeah, we have to check because otherwise,
let's mint 1 million NFTs. 1 million.
Yeah, I have a function to do it, batch function. Yeah, but I mean, just it will be very interesting surprise for the developer if he will just push his application, but then as soon as his state will hit some limits, then it will just stop working. Maybe
I've done it on Ethereum, and it's the same philosophy. So basically, I did a view call and tried to pull back like everything I could, and it eventually just ends. Like it just says, sorry, too much. Like
I think it was out of gas. It'll say error out of gas on a read, which is really funny.
Yeah. It's something like that. Anyway, yeah, it's so funny because it has that memory thing, and then so it basically is something to do with just the node itself loading into memory, blah 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 blah. But here we've given the developer every tool that they need in order to do it correctly. You know, so we just sort of are going to have to go with that. Hey, by the way, if you want to see what an NFT looks like, because of all this optional metadata, they end up looking like this. There's a few NFTs here because I've run the test, I think like several times. They're all the same media type, but I think that they're generated with random token IDs. I think these are based on like the date or whatever, or something. I just like add a 1 onto date.now. It's just bullshit. But anyways, you know, that's kind of what an NFT looks like, which is kind of cool when you call, you know, show me the NFTs. So anyway, that's enumerable. So there's different ways you can access tokens. kind of cool. Let's talk about the next thing. Let's talk about payouts, actually. So this one was new. Sorry, I'm just like, I sound exhausted. It's because I'm like, every time everybody gets together, I have to look around my microphone here. Every time everyone gets together and talks about NFT standards, somebody's got some new way to do shit. I spent so long working on that diagram that we talked about last time, where we had like, you know, the call for the royalties and then the callback and all of that other stuff. But actually, hey, I can share with you the new diagram. It's much more simplified. Here it is. It's already loaded. So we're talking about fungible token sales. So that's step one. We have to actually approve. Well, it doesn't have to be a fungible token sale, but we have to approve a sale, approve the sale args. So we have sale args go into the market. And then what happens at that point? What happens at that point is that the owner of the NFT has approved the marketplace to transfer the NFT on their behalf. But the owner also, presuming they're on the marketplace's front end as well, the marketplace let them fill out some sort of sale arguments. So like in my market simple contract, it's like, what would satisfy the transfer of the NFT? What would satisfy the seller? So sale args is simply a price and an optional fungible token that the price is denominated in. So for example, I want to sell my NFT for 100 near, or I want to sell it for like, 500 bridged DAI tokens. So I could specify exactly what I want. I'm working on an upgrade that would allow you to actually specify multiple token conditions. So you would have like, I'm willing to accept this much ETH, this much DAI, this much near. And then you can update each price if you want. Like you can say, update the price of my sale for which token for ETH, change it to 1.5 ETH, for example. So anyway, that's an update coming. But long story short, the user approves the sale args come in. They're just these JSON stringified args that say basically price and token ID that is willing to accept for that price. And now comes the interesting part. So how do you actually purchase that NFT? Well, you first send fungible tokens to the NFT contract, to the marketplace contract by calling FT transfer call. And you're also passing in, simultaneously, you're passing in purchase arguments. And you need to pass in purchase arguments because you need to tell the marketplace which NFT contract and which token ID inside the NFT contract are you willing to purchase, like based on the fungible tokens that you're sending. And in this case, we're only looking at the fungible token case. The near case looks like this. You just call market directly, and you just call a function called purchase, with, purchase args in here. And then, attached deposit of near. So your attached deposit of near needs to match exactly the sale price if it was denominated in near. But anyway, let's keep going with this one. So FT transfer call. Now the marketplace contract has a method that accepts fungible tokens, and that's called FT on transfer. It's part of a trait that we defined in our spec called, well, you can look at it here. It's called the core standard. It should be here. There's like this needs to be organized. Here it's FT on transfer. So there's a trait here called a fungible token receiver in Rust. So if you are a fungible token receiver, this is all written in TypeScript. Boo, TypeScript. Just kidding. I say TypeScript. No, I always call it ActionScript. Assembly script. That's the assembly script folks, writing the spec. But anyway, in Rust, it's a trait. You can see it here in the newly organized marketplace, my market simple here. So the trait is a fungible token receiver, FT on transfer. This doesn't really matter, this trait, crap, but basically this this contract should implement FT on transfer. And then if we go back to that diagram, we basically receive the fungible tokens here in this method. And then the next thing what we do is we obviously check the sale, check the price, check that it accepts that fungible token. So check everything, right? And then only then do we continue on with NFT transfer. So what we do is from the marketplace, we call NFT transfer, and we also pass it a balance argument. So this is the part that I wanted to talk about with regards to payouts. So if we look at NFT core, and this, by the way, this needs to be updated in the spec. It's not, it's been proposed, and Mike, Eugene, Thor from Mintbase, everyone told me this is the way it's going to happen. So this is what I did. Hang on one sec. NFT transfer. Okay, so remember, the marketplace has already been approved to transfer the NFT, so it can transfer the NFT. It just received fungible tokens or near, so it will transfer the NFT. So then when it calls transfer NFT, what it actually passes in is a balance field. So the balance is the balance that the marketplace currently has pending a successful transfer of the NFT. So what ends up happening is market calls, let's go back to the diagram, market calls NFT transfer, and then schedules a callback for itself. The marketplace schedules a callback to itself for resolve purchase, checks the status of the NFT transfer, and also receives in that promise that it's checking, if the promise was successful, so the NFT was successfully transferred, it receives a payouts hash map. And I'll show you what the payouts hash map looks like. So again, pass a balance field saying, hi, I'm the marketplace, I'm transferring this NFT. By the way, I also have a balance of tokens. I need to know where to put these tokens. So then it comes through here, transfers. This is a successful NFT transfer. And now what we're going to do is we're going to compute the payouts based on the balance option. So what we do is I added a royalty hash map of account ID safe fraction to my tokens. So the tokens that are in my NFT contract. So I know who should get what in terms of percentages. And what I do is I go through, I say, let the payout equal if there is some balance. Remember, it's an option to payout as well. So it's an optional payout. So I say, okay, if let payout, it's going to be equal to some, if there is some balance defined, it's going to be equal to this or none at all. So there either is going to be a payout or there's not going to be a payout. In either case, we're going to update the owner royalty. So we're going to swap the owner royalty to the new owner. So the new owner gets the royalty that the previous owner used to get. So previous token dot owner ID, right? We get the owner royalty. Then we insert into the token royalties the sender ID, and we give them the owner royalty. And then we update the tokens. So anyway, okay, that was a lot of stuff, but let's go into just this calculating the payout. That's the last piece of the puzzle. So how do we know who gets what out of the balance? So let's say some balance comes in, 100 near tokens, right? So it says the balance is 100, right? So balance, first of all, I just convert it just for convenience because I'm going to use it inside this loop. Then I get this mutable payout, which is a new hash map. And then I loop over the token royalties. So remember, these royalties are of the type safe fraction, and it's account ID pointing to some fraction, right? So then I say, okay, I get the key, and then I insert into payouts a new key, and then I multiply the value, the safe fraction, I multiply it by a balance. And that was because of Thor's Thor from Mintbase has this nice safe fraction type that he put together, and you have a fractionalize a balance. So it basically just multiplies. It's like a multiplication for some balance. So it's just convenience method, right? So then I insert that into the payouts. Now we have this payouts hash map, and now we know exactly which balance to pay who. So now the question is, going back to the diagram, once we get to resolve purchase with this payouts hash map, what do we do, right? Like where do we go from there? Okay, well, we go back up to the market and we go to, it's in sale here. Resolve purchase. Okay, sounds kind of like, or it looks really nasty, by the way, just warning. But basically this is resolve purchase. So this is the callback after the NFT was transferred. So now what we're going to do is we're going to go through this and we're going to start processing the promise. So the first thing we look at is we look for a payout option. So remember, it was an option that we got back from the promise. So the question is, what do we want to do with different promise sort of scenarios, right? Actually be a lot cleaner if I move this up here. Anyway, so there's a few different states that the promise could be in. So it's not ready, it failed, and that in that case, we don't have a payout. And I'll show you how we handle a no payout scenario. So we are a marketplace and we want to respect royalties. So we want to only complete sales for NFT contracts that give us a payouts hash map. So we're kind of making some assumptions here, but just go with it for a sec. So then next we have promise result is successful. So this actually, in this case, the NFT has been transferred. So it's already, the NFT is already transferred to the buyer. Now the question is, how do we handle the tokens that are inside the marketplace contract? Well, first, what we do is we try to go get a payout value. If it's this is a little bit of like weird Rust voodoo, but we check if it's okay, and then we basically look for we take the payout in a closure, and then we start to go through and process like just what kind of a payout is it. By the way, if this was not okay at this point, this closure will not happen, and this will not panic, but instead return none. So it would go back out and we would return none here. And then we handle the none case later, but let's focus on the different types of payouts that we could receive. So there's a couple of things that we want to check. Like, so for example, do we have enough gas? So we can only cover 8 fungible token transfers. I've done some testing around this, but with 200 teragas attached, you can only really do 8 fungible token transfers if you received fungible tokens in the beginning. Because when you receive fungible tokens, you're already down 30 teragas. You're down to like 170, and then you start using it up. So I think it takes about 130 teragas to do these 8 fungible token transfers and wrap up this resolve purchase method. But I mean, your mileage may vary. You may figure out a way to do something else, right? And obviously, if the payouts were in near, this would be a lot cheaper because we would have never received fungible tokens in the first place, and we could probably pay, maybe do like 12, 13, 14, 15. I don't know how much it costs to transfer near, but basically I like to just test with these things and then put like a limit on it. So anyway, if payouts length is greater than 8, then we'll return no payout. So we'll say there's no payout option. We can't pay people, too bad. Payouts must equal sale price. Otherwise, something went wrong with the NFT contract. By the way, you guys will probably figure out like, 3 or 4 different exploits here if the NFT contract is like quote unquote bad or malicious. Like, did it send more payouts? do the payouts values sum up to be something other than the sale price? I mean, all of this stuff is possible. But basically in this case, it's the marketplace kind of protecting itself from making like ridiculous payouts. So there could be a malicious NFT contract and it could have royalties per token, but then it could have an owner only method that injects more fractions. So it says like, oh, you got to pay out more. You got to pay out this much. And then the marketplace contract gets called. And if it wasn't checking that the sum of all of the royalties equals the sale price, like the sum of the payouts that the NFT contract is telling it to pay out, if it doesn't check this, then who knows? Maybe the marketplace contract has near inside it and it just starts paying out, like pays back to the NFT contract. Who knows, right? Could be doing anything, right? So anyway, by the way, this isn't a walkthrough on security. It's just a walkthrough on practicality, like, build an app, let's get it to work, and then we'll take it for like a much more rigorous kind of audit. I also literally implemented this yesterday, so let's take it easy. Anyway, long story short, we do some checks. We just want to make sure, is this a reasonable sort of payout hash map that we got from the NFT contract? And then if it's valid, then it's good. We'll just unwrap it, right? And then if it's not valid, what we're going to do is we're going to send the tokens back. So we're a marketplace. We checked as best as we could the payouts we got from the NFT contract. We determined that it's just not very valid. And so what we're going to do is we're going to pay back everyone. There is one issue here, and I've kind of struggled with this myself. There is the issue of, should we transfer the NFT back or not? And the issue with this setup right now is that all we have is that the payout option is none or some. If it's some, it's good. We're going to trust it. If it's none, it's none at all, right? So in this case, though, the NFT was transferred, but we still had the NFT contract send us malicious payouts, right? Like bad payouts or malformed data. So what we did was we actually refunded the buyer, but we didn't transfer the NFT back to the seller. So we have kind of a problem here. So there are issues and like shortcomings here. I totally acknowledge it's not perfect yet. But anyway, that's the end of it as it stands right now. And it definitely needs some more work and stuff, but that's the implementation, just a very rough sort of, testnet worthy implementation to kind of poke around with. And then we have royalty. So we just log it out and then we just pay. And it's very easy to pay these royalties because it's just account ID and amount. And so we just go transfer. And that's it. So these are the fungible token transfers. And then these returns here. So it's kind of weird. Like if the sale was not denominated in fungible tokens and it was denominated in near, this method returns the number of tokens, if we were sent fungible tokens, the number of tokens that we did not use. And so obviously if the sale was denominated in near, you want to return sale price. And here, if you're refunding, so if your payout options were bad, you're refunding the sale price in fungible tokens. So you're sending all the fungible tokens back to the buyer. Likewise here, if for some reason you got here, which you'll never get there really if you're sending fungible tokens. But then here at the end of this, basically we just send back 0, which indicates to the fungible token contract. So let's look at the diagram here. So after FT on transfer, there's actually, I'll show you, there's actually something happening behind the scenes here. There's actually this is happening. So it has like a, there's like an extra little thing happening in the FT contract. It's FT resolve transfer that was not diagrammed because it's not important if everything goes according to plan. But basically FT resolve transfer takes back the amount of tokens that you didn't use, and it refunds the sender. It also, by the way, it also refunds if it panics. So if you call FT transfer and you call FT on transfer and you call NFT transfer and it panics here, it would actually do resolve transfer and it would check the promise and it would refund if this contract still had those fungible tokens, for example. So anyway, wild ride. It's pretty fun, actually. Like the fact that it's all async and like things are just zooming around. Once it sounds complicated, but once you get the hang of it, it's pretty powerful. The number one pattern, I would say, like the number one thing that, I've learned, like just by working on Near and by going through this process several times, is always like your answer to most cross-contract call scenarios is to have a scheduled callback to yourself, to your contract. And in this instance, you want to handle the several different possibilities of what happened with the contract that you did call. So you want to basically clean up and handle all those cases.
I have a question about that, actually.
Yeah, sure. Go ahead.
Is it possible to deploy a contract and schedule a call to that deployed contract upon success?
Yeah, it is. You have to create an account though for the deployed contract too, right?
Well, the account would exist, but you can deploy to the account, right?
Sure. Yeah. That's a good question.
Or is it only for a created account?
No, it's you can deploy a contract to an account and then do a .den call. Link drop's not here. I don't know where the link drop.
Link drop's a separate repo. Yeah.
So it's so bad.
Yeah.
I just link drop. It's gonna find like so many different. Oh, here.
Yeah.
Okay. Number 2, not bad, Near. So yeah, it's the only thing I'm going to show you is that it follows the same pattern as this. So promise new, and then here what you're going to do is you're going to do deploy contract, or like deploy contract bytes,
and passing the bytes.
And then here you see .den. You're gonna do a callback to your own contract when all of this is done. And then when all of this is done, you do a callback to yourself, and then you can go inspect that contract. Like you can go call that contract and say, hey, what's going on? Like, so what you would do is you'd actually call deploy contract, and then you would call function call on that promise. And you would say, call new, provide it with some args, etc. And then on the .then you would call yourself, and then you could make another external contract call back to that contract and say, or no, you'd probably just want to grab the promise and say, hey, what was your contract deployment set up successfully? But you could also kick off another cross contract call and just say, hey, I'm now, like, I deployed you and I called new. Now I'm back in my own contract, and now I'm calling you again to see if you're set up and you are in fact okay, So you could do that. It'd be fun. I don't know how useful that is, but yeah, totally possible. It's starting, I got to be honest with you guys, it's starting to get really good, like in terms of these cross contract calls and standard sort of ways of dealing with certain things like refunds, and near was sent and now it needs to be sent back, things like that. It's starting to get really good. The last thing I wanted to talk about was the the optionality of taking in a sale. I have a branch here. Oh, it's bad. It's what changes did I make? Whatever. This is bad. Something. I don't know what I did, but I did something. So I wanted to show you my latest idea, and you guys could poke some holes in this maybe. So let me explain what I'm trying to do. So I'm trying to create in the market simple contract, I want to create the ability to do two new things. And I explained it to you guys, but this was before we started recording. So I'm just going to explain it quickly again. So number one, what you just saw in the market simple contract was that you could only put up your NFT for sale in one token at a given time. So one token at any given time with one price. So you could only say, sell your token for near, or, like Ethereum, like bridged Ethereum on near, or bridged DAI on near. You could only sell it for one token at any price at any given time. That kind of sucks, right? Because you may want to accept multiple token types. You just want to sell your token. And you can set these fixed prices. So that's the first part that I'm trying to do. I'm trying to basically turn, instead of having sale, the sales struct have price and fungible token ID, I'm going to basically have conditions. And conditions are going to be a map of fungible token ID to a price. So the thought process here is that every sale has conditions, and it's a hash map of fungible token IDs to prices. That satisfies part one, which is that you can have somebody post their sale and have multiple conditions, right? Like that's pretty standard. So I could say, fungible token ID, DAI contract, this price, bridged ETH contract, this price, right? Now, the next thing we want to do is we want to be able to also leave the price part open. So leave it open-ended, in which case, when a user goes to send, fungible tokens to this contract and it matches a fungible token on the sale, but the price is like, let's say the price is like 0 or an empty string or something, something should signify, it'll probably end up being 0. That signifies that the price is currently open. It's open for negotiation. And then in that case, the buyer's deposit is going to be left in the marketplace contract, but their deposit is going to be stored in a data structure of bids for that token. So what's going to happen is probably actually on the sale itself, I'll attach like some data structure like bids. I'm soliciting feedback now. Please help me. So I'll solicit like bids, and a bid will be, it has to be from a particular, hash map. It has to be from a particular person. I'll probably have to make a whole new struct for this, call it a bid, because every bid has to have an owner ID. So it's going to have to be just a hash map of it's probably going to be the owner ID mapped to a bid, and a bid is basically just going to be two things. It's going to be the FT token ID and the price. So in this way, what we're going to have is we're going to have the ability to, I'm not sure if that's the best way to do it. Oh, no. So sorry, there should only be one bid that's active for one token type at any one time, because if Vadim bids with 100 DAI and I bid with 110, it should refund his bid and put my bid there. So bids will actually be the fungible token ID, and then it'll be the bid, and that will be owner ID and price. Go ahead, Vadim. Sorry, I interrupted.
Yeah, I just had a concern. Do you think this flow is viable? Because how people will set prices which are so volatile? Because maybe I just want to set one price and I tell, for example, I want 100, for example, DAI dollars, and I will accept others near, and you can just take price from AMM and put it to me.
Yeah, I'm not going to do that because I don't want to take the price from the AMM. So I'm going to do it. I'm going to do this. I'm going to do this implementation first, and then I'm going to do the next one, because the reason
I'm sure somebody will use it, because for me it's very complicated. How shall I predict price of? Okay, I will always sell for the worst price, right? For example, if I don't know, Ether grow up, and I will sell for DAI.
Yeah, that is a good point. But when you're accepting bids, you should be able to accept bids of any token, right? So, I mean, you want to open it up to be like any token.
How do you know value is different between different tokens? Like 100 DAI and maybe 1,000 0x or something. Like wrapped near. How do you know wrapped near is greater value than DAI?
So you don't, but what you would see. So are we talking bids, or are we talking fixed price?
On the bids, because you're talking about replacing bids by the higher value. So if you're doing all these tokens, you have to somehow compare value.
No. Only the bid of that token gets replaced.
The same type. Okay.
Yeah. So basically in your token, so imagine a user interface, it's going to show, Matt's NFT, and then it's going to show Vadim bid 100 DAI, Trevor bid, 50 BAT tokens, whatever. Right. And if I outbid any of you guys in your particular token type, I replace you.
Maybe shall we rename type from account ID to token ID to clarify this?
Yeah, it should be fungible token ID actually.
And how are these being closed? Like, is the owner closing and accepting the bid of their choosing for the token type, or is there an automatic close with the valuation?
So that's where I think the owner of the sale comes in, calls the sale contract, and at that point they don't have to accept the highest bid. They could just accept the highest bid of the token. Well, it's always going to be the highest bid of the particular token, but they don't have to take the correct token. So on the user's front end, what they're going to see is I'll pull in like CoinGecko price feed or whatever for those token types, and I'll show them all the US dollars, and I'll sort the list. But they don't have to take the DAI. Like let's say they just really want the ETH and it's off by like $10, they'll take the ETH,
Interesting. Okay.
I'm not here to try to build people's apps for them, and I'm not here to build the best application. I'm just here to build a application, or a reference application that people can say, oh, hey, there's all these ideas here. They're all laid out. I could clone this, take out this part that like the fixed sale price stuff, like, because Vadim pointed out, it's kind of stupid, like somebody's willing to accept 100 Ether. I mean, actually, Vadim, this could be kind of cool though. Like, what if I was willing to accept immediately 10 ETH, but I left open bids for DAI and other tokens, right? So immediately right there, it says ETH, like bridged ETH 10, and you get it right now. And that's in a list of a bunch of other tokens, right? So there's bids, but there's an indication that the seller wants something that wants sort of like a top end bid. So that could be a scenario. But anyway, again, the point is like, I'm not trying to like, you know, I don't want to launch a marketplace, to be honest. I don't want all that headache. I'll let somebody else can launch their marketplaces. But what I'm trying to do is I'm trying to help everybody launch their marketplace by just providing, you know, the contracts. It's just free. Go ahead, use it, you know. By the way, no warranty, no security audit yet. So you should probably talk to somebody before you go on mainnet with these kinds of contracts. But yeah, anyway, we'll see how it turns out. But yeah, I mean, I think having sale conditions, and then again, good point, Vadim. You know, I should really be very explicit about what these things are. And then bids are in a particular fungible token ID, and it's a bid from a particular user. So we have to have an owner ID, and there's a price to the bid. And then long story short, I mean, this should also be, you know, this could even be a type just to make it really explicit, you know. It's kind of a little bit going overboard at this point, but just to make it really clean, it's going to be like this, right? Oh, I already have a struct called price, so that might cause some issues, so I'll take that out. But long story short, the ergonomics of it, I think, are going to be basically that such that a user can say they want to sell something, they specify the tokens that, so at the base, they're going to specify the tokens that they'll accept bids on. Then they can set a fixed price. So they can set a top end price, which would execute immediately if satisfied. And that's it, like full stop. And every time there is a bid for one fungible token type, it will kick out the previous bid of the other fungible token type, should it be greater. But that's the only time you can actually bump the other person. If you're not greater, it's just going to return to you your fungible tokens and say, sorry, we didn't use your fungible tokens because you ain't a baller. Actually, I might put that in the contract. You ain't a baller. Token refund. What do you guys think about that?
There is one edge case here. I don't know if you thought about it before. For example, if somebody will put fungible token ID, which he doesn't initialize on his account, he will never have those tokens because he have to call storage balance before. You know this stuff. So there are two functions. For example, if you want to transfer DAI to your new account, first you have to call storage deposit.
Right.
Then you will create account on a fungible token contract, and then you can send tokens. So if somebody will put here his,
you figured it out.
Do you have it?
No, I actually don't have it, but I'm gonna write it. I'm gonna write it down here somewhere.
Yeah. So before to withdraw, we have to check. A good thing that we can call on behalf of users this function.
Yeah. So basically, when the seller goes to add the sale, what we have to do is we have to check the storage deposit, and basically make sure that all those storage deposit promises return successfully. The other aspect, like the other side of that, though, the other flip side of that, Vadim, is that when the sale actually happens and then the owner payout is made, so when you go to pay out the royalty, so there's this part of the contract, resolve purchase, right? So when the owner is being pulled, sorry, it's here for fungible token transfer. When the owner is being paid out, what you could check is you could do a .then, and then right? So what you could do is you could do a dot then, check that the fungible token payout to the owner was successful, because, and if other, well, here's the thing, it starts to get worse when other royalty owner holders like don't have the token type. So it just gets worse and worse and worse, right? So, you know,
I guess we have to update contract fungible token factory to make this automatically. Just spend some tokens from gas to create the storage, if it's possible. Or no, it will be too expensive, right? Yeah, I think that's the reason why they didn't put it.
What I would do at this point is if you were to be like a good actor as a marketplace, you would store an escrow for these people. And then you would basically have a callback, check the promise was successful. And if the promise failed, all you need to do is have receiver and amount. And then what you do is you check, you're going to have an escrow lookup map, and you're going to basically pull the balance, increase the balance by the amount, just keep going up for that user, and then put it in. And if the FT transfer fails, or no, you need one more piece of the puzzle. You need the actual fungible token that it's denominated in. So basically, it's kind of like you would have a lookup map to a lookup map. So you would have, you know, for a particular user, I have escrowed these token types with these amounts, that kind of a thing. So you would just have to keep that. I do think though, Vadim, that this is like a little bit too almost like a bridge too far, and that there's some issues that on the client side, I think that the marketplaces and the early NFT contracts should actually check. So for example, think about this like permissioning all the way through. NFT contract, when it first launches, it only approves one marketplace. And the marketplace plus the client side, the front end to the marketplace, which has all the abilities to call the view functions of the fungible token contracts. So the user selects from a dropdown, I want to accept DAI. That's a front end interaction, right? And when the user says, I want to accept DAI, the marketplace front end should say, hey, I'm a good marketplace. I better check to make sure they can actually receive payments in DAI. And by the way, I see that their friends are all receiving royalties too. I should probably just prompt that user to set up their storage deposits for their friends or their royalty deposits. You could also do this actually when you mint the NFT. So when a user comes to create an NFT, they could actually set up some fungible tokens. So they could say, hey, you're in the NFT contract and let's say you approve, you want to kind of forward think through some of the royalties. So you want to accept royalties in DAI or Ethereum or whatever. And you would just prompt the user to, like you say, hey, I haven't seen that person on the royalties. Seems like they're a new collaborator of yours. Did you know that they can't accept DAI or whatever? So you show that on the UI and you say, do you want to set them up? And just be like, yeah, register them for DAI payments, register them for Ethereum payments. So you can either do that in the NFT contract when you split royalties, or you could do that in the marketplace when you set up the sale, right? But again, you know, when are we going to do it?
Maybe it's a good opportunity for some like third-party contract which will provide this functionality. Like somebody will deploy a contract which will handle these tokens, sending fungible tokens. If somebody doesn't have account, it will just store and let's for this person to come and take it back later. Did you get me?
Oh yeah, like an
And
escrow,
then
or just why not just open yourself up as I am the batch fungible token registry, right? So, send me your friend's account ID and a tiny bit of near, and I'll pre-approve them in 10 different fungible token contracts.
yeah,
Not bad. I mean, I like the escrow contract idea too. I think that that's pretty cool. Like being sort of like a you're you're a fungible token free port that's prepaid. You're
yeah. And I guess
non-taxable. The funds are just sitting there.
yeah, and I'm kind of sure you will be able to get rid of that limitation for 8 royalties amount, maximum 8, because I think this limitation came especially from callback transfers.
Yeah. Hey, by the way, here I'll connect you with some other ideas. We were on an NFT standards call, and the royalty limit was brought up, and I'm going to stop sharing now. Actually, I was just sharing my screen the whole time, but whatever. This is a good discussion. So the royalties limit was brought up, and the way to expand the limit to like a DAO or a collective, I just have to check my calendar too. Just give me one sec. Yeah, there's nothing going on. Okay. Nobody invited me to anything. I'm just kidding. I'm actually glad, super glad. So this was brought up, the limit of like how many royalties can you pay out? And then somebody says, but what about a DAO? What about paying out all the members of a DAO? And this exact topic we brought up, Vadim, where you would just pay the DAO contract, like quote unquote, the DAO contract proper. And the DAO contract should actually have a like a received members dividends kind of standard. And then basically the DAO contract takes in 100 fungible tokens. It has 50 members, and then it itself has a fraction of royalties based on those members. And then you call the function, you say, okay, I'm part of the executive. I have a higher percentage than just another person. So somebody gets 1 fungible token and some of the executives get 3 as opposed to everyone getting 2, so things like that could happen. And then of course, over time, you just let the escrowed payments build up in the DAO contract. And then you just have people pick away at them with their fractions, like whenever they want. So could be cool. I like that.
So we are doing this for DAOs, right? I didn't catch it before. So,
no, I was giving the example. So somebody gave the example and they said, what if the royalty receiver was all of the members of a DAO? And then I just said, I was like, you know what, guys, like at that point, this is no longer an NFT standard and like some payout. Like this is more complicated. Like, because that's when like one standard creeps into another. Like, why should the NFT standard handle like, how the DAO distributes its funds or dividends of activities to its members, right? So I do agree that we'll cross that bridge, because the way that we iterate, like with these contracts and these sort of concepts, like we're iterating really fast. We'll probably come to like the convergence of an NFT and a DAO very, very quickly, and then the DAO will be a royalty recipient, but then the DAO will have to implement like a safe fraction dividend payout to its members of various tokens, right? So that was just like an example. But I do agree with you, like having like a generic escrow contract that can receive a royalty, and then members can go, and then that contract is the only contract that has to register for the fungible tokens. That's really cool. That's a good idea. But hey, let's stop recording. So if anybody actually made it to the end, congratulations. You've probably wasted some time, maybe got some good ideas, don't know.